Hello dear students, good morning to all of you, and once again welcome to the lecture series on Laplace transform. So in the previous lecture session I was discussing about the properties of Laplace transform, in which I have discussed total 5 properties. So in this lecture session I will start from the sixth properties, which is Laplace transform of derivatives. Laplace transform of derivatives. Let ft be a continuous function. Let ft be a continuous function of t such that L of ft is equal to f of s, then Laplace transform of f dash t, which is equal to sfs minus f of 0. Okay, so if you are given the time domain signal or time domain function ft, then the Laplace transform of f dash t. What is f dash t? F dash t is nothing but it is the derivative of ft, that means d of ft by dt. Okay, so we have to find the Laplace transform of d of ft by dt, which is given by s of s into fs minus a small f0. Okay, so this is fs is basically the Laplace transform of ft. Okay, and what is this fc? F0 is the value when we put t is equal to 0 in time domain signal or time domain function, that is a small ft. Okay, so this f0 comes by putting t equal to 0 in this ft. Okay, this ft. Okay, this ft. Okay, now then what will be the Laplace transform of double derivative? L of f double dash t, L of f double dash t, and f double dash t is double derivative of ft, that means d to ft upon dt square. And what will be the Laplace transform? The Laplace transform will be s square fs minus s f of 0 minus f dash 0. Okay, so here f0 is what? F0 is basically the value of ft when t equal to 0. Okay, and f dash 0 is the value of derivative of ft. Okay, matlab d of ft upon dt at t equal to 0. Okay, then Laplace transform of f triple dash, that means triple derivative of ft. Laplace transform of triple derivative of ft is given by s cube capital Fs. Okay, What is capital Fs? Capital Fs is the Laplace transform of ft. Okay, so s cube Fs minus, here minus s square f of 0 minus s f dash 0. Okay, s f dash 0, after that minus f double dash 0. Okay, this is the Laplace transform of triple derivative of ft. Now I am interested in finding the Laplace transform of nth derivative of the time domain signal or time domain function ft. Okay, so in general, what will be the Laplace transform of nth derivative of ft? Okay, so in general Laplace transform of fnt, this is basically the nth derivative of ft, which is equal to s to the power n capital Fs minus Sn minus 1 f of 0 minus Sn minus 2 f dash 0 minus Sn minus 3 f double dash 0 minus dot 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 minus. And what will be the last term? So the last term will be f of n minus 1 0. Okay, so if you put here n is equal to 1, so first derivative, okay, so first derivative, then put n is equal to 1 here, then s fs minus here 1 minus 1 0, s to the power 0 is equal to 1, so only f0. If you put here n is equal to 2, then double derivative, then s square fs minus 2 minus 1 1 s f of 0 minus here 2 minus 2, which is 0, so s to the power 0 is equal to 1, so you will get f dash 0. Okay, so this is the general expression or general form of the Laplace transform of derivative of ft. Okay, so come to the next property, which is Laplace transform of integrals. Okay, so Laplace transform of integrals. So what will the Laplace transform of integrals? If L of ft is equal to fs, then Laplace transform of integrals, right? Integral, that means 0 set to t, the limit of integral is 0 to t ft dt. Okay, then Laplace transform of this is given by fs by s. Now this is the seventh property, and now eighth property. Eighth property is Laplace transform of function, Laplace transform of function multiplied by some powers of t, multiplied by some powers of t. Okay, So Laplace transform of TFT is minus f dash s. Okay, so this ft, the Laplace transform of ft is fs. Okay, then if we multiply this ft by this t, then the Laplace transform of this whole will be given by minus f dash s. Okay, so you know the fs, this fs is the Laplace transform of ft, and you just derive this fs with respect to s, and then take one negative sign, then you will get the Laplace transform of tft. Okay, here f dash s is what? F dash is nothing but d of fs upon ds. Okay, right? So in general if here t square, then t cube, then in general we can write in general the Laplace transform of t to the power n into ft is given by minus 1 to the power n fns. So what is fns? Fns is nothing but derivative of fs, n times derivative of fs. Okay, that means dn fs upon ds to the power n. Okay, so if you put here at place of n, if you put here 1, so you just get this. Okay, so Laplace transform of tft is equal to, just put here 1, then minus 1 to the power 1 equal to minus, okay, and here 1, so f dash s. Okay, one time derivative. If you put here 2, then Laplace transform, put n is equal to 2, that means Laplace transform of t square ft, which is equal to minus 1 to the power 2 f n, put here 2, and so simply you can write here minus 1 to the power 2 is equal to plus 1. So here f square s, here s square is nothing but double derivative. Okay, so write here double dash, f double dash s. So what is double dash? F double dash is nothing but double derivative of fs with respect to s, that means d2 fs upon ds square. Okay, so this is the Laplace transform of the function ft when we multiplied that function with some powers of t. Okay, now so the next property is, so our next property is when we divide ft by t. So we can write here Laplace transform of function divided by t, or function divided by t. So if you are given L of ft is equal to fs, then Laplace transform of ft upon t, which is equal to integration s to infinity fs ds. So this is the Laplace transform of a function when divided by t. So just remember one thing, Okay, this is a technique to remember this properties. Okay, when you are going to find out the Laplace transform for derivatives, then here you get multiple form. Okay, that means if you have to find the Laplace transform of derivative, then in the result you get the multiple in multiple form. That means what? S into Fs. That means S will be in multiply with Fs, S or S square, that depends upon the derivatives. That means first derivative or second derivative or third derivatives. Okay, so you just simply write here Laplace transform of, what was the Laplace transform of f dash t? Simply sfs minus f of 0. So here here I am finding the Laplace transform of f dash t, that means derivative. So in the result what we are getting? Multiplying in multiple form. Okay, and if you have to find the Laplace transform of integration, then you get here in the division form. Okay, that means integration. So see the property number 7th. Okay, so what was that? That means Laplace transform of integration 0 to t ft dt, then the result was fs by s in डिवीजन फॉर्म. दैट मीन्स अगर इधर डेरिवेटिव होगा तो इधर आपको मल्टीप्लाई फॉर्म में रहेगा. अगर इंटीग्रेशन का आप लाप्लास निकालते हो, ठीक है, इंटीग्रेशन का लाप्लास निकालते हो तो क्या होगा? आपको डिवीजन के फॉर्म में आएगा. अब इसका उल्टा अगर मल्टीप्लाई करते हो, मल्टीप्लाई मतलब अब टाइम डोमेन फंक्शन में आप अगर मल्टीप्लाई फॉर्म में करते हो, जैसे लाप्लास ऑफ टी एफ टी मल्टीप्लाई फॉर्म में है, तो आपका रिजल्ट जो आएगा इसका लाप्लास ट्रांसफॉर्म वो क्या चीज़ में आएगा? मल्टीप्लाई का. तो मल्टीप्लाई का आपका क्या चीज़ में आएगा? डेरिवेटिव्स में आएगा. ये याद रखना है, डेरिवेटिव्स में आएगा. ठीक है, जैसे यहाँ डेरिवेटिव्स लिए थे तो मल्टीप्लाई फॉर्म में आया था. अगर इंटीग्रेशन करते हैं टाइम डोमेन में तो हमको एस डोमेन में क्या चीज़? डिवीजन फॉर्म में लिखाएगा. अगर मल्टीप्लाई फॉर्म में दिया हुआ है इधर, जैसे टाइम डोमेन में हमने सिग्नल को मल्टीप्लाई किया टी से, ठीक है, तो आपका जो आंसर जो आएगा इसका लाप्लास ट्रांसफॉर्म जो आएगा वो क्या चीज़ आएगा? डेरिवेटिव फॉर्म में आएगा, माइनस एफ डैश एस. इसलिए यहाँ डेरिवेटिव लिखा हुआ है, डी फॉर डेरिवेटिव. ठीक है, यहाँ डी है डेरिवेटिव्स. ठीक है, उसके बाद अगर आप डिवीज़न का करते हो, डिवीज़न का लाप्लास ट्रांसफॉर्म करते हो, तो डिवीज़न का लाप्लास ट्रांसफॉर्म क्या आएगा? यहाँ देख लीजिए, जस्ट इंटीग्रेशन फॉर्म में आएगा. यहाँ डिवीज़न था तो कैसे में आया था? इंटीग्रेशन में आया था, तो यहाँ इंटीग्रेशन में आएगा. तो ये याद रखना है आपको. ठीक है, इंटीग्रेशन फॉर्म में आएगा. तो ये टेक्निक है याद करने का कि अगर डेरिवेटिव का लाप्लास ट्रांसफॉर्म ले रहे हो तो मल्टीपल फॉर्म में आएगा, अगर इंटीग्रेशन का लाप्लास ट्रांसफॉर्म ले रहे हो तो डिवीजन फॉर्म में आएगा. इसका जस्ट उल्टा, अगर टाइम डोमेन में मल्टीपल फॉर्म में है तो डेरिवेटिव में आएगा, टाइम डोमेन में अगर डिवीजन फॉर्म में लिखा हुआ है तो आपका इंटीग्रेशन में आएगा. ठीक है, तो इस तरह से प्रॉपर्टीज़ आपका कंप्लीट हो गया है ना. अब हम लोग इन द नेक्स्ट लेक्चर वी विल सी सम प्रॉब्लम्स बेस्ड ऑन द लैप्लास ट्रांसफॉर्मेशन. ओके, राइट. सो ठीक है, थैंक यू.